Well, good morning, everyone. My name is Peter Sirota, and I run engineering at Quantcast. Today, we'd like to share with you how we do forecasting on the internet using large amounts of data. Quantcast is a net tech company, and it has several lines of business. Measure, that helps publishers, websites of various sizes, understand the audience, and Advertise, that offers several advertising products to marketeers. In this talk, I'll briefly describe how those two products work, and then we'll dive into the modeling and machine learning, which basically we use for various forms of forecasting. At the end, we'll share a couple of fun trends that we've observed with some of our publishing and advertising customers. Quantcast Measure helps publishers understand their audience. And again, by publishers, I mean basically website owners. As a customer, Yelp in this example, you tag your website page, and then every time anybody visits your page, we record that event in an anonymous way. From the events, we generate demographic data, and then we present that data to Yelp in an easy-to-understand set of tools and capabilities. In many cases, the data is actually publicly available, and anybody, including yourselves, can go and check it out. If you come to Quantcast.com and search for Yelp, you'll see that about 31 million people visit their site weekly. And as you can see, recently it's been dominated by mobile traffic. You see that the audience is heavily indexed on people between 25 and 35 years old, Asian, Democrats with large income. Their interests include food and drink, not surprisingly, and they're 20 times more likely to visit OpenTable.com than an average internet population. Quantcast Measure is a free product, and a lot of sites are using it. And it's a useful thing to understand who is your audience, who comes to your site. Quantcast Advertise works in a following way. We tag a conversion event on an advertiser's site. For example, a purchase button on a flowers site. Then we model consumption patterns of customers that purchase the flowers. And then based on those patterns, we identify ideal prospects on the internet, and then we target those consumers at scale. It takes several components to be competitive in this advertising industry. You have to have a global network to collect events. You have to have significant transaction processing infrastructure. You have to have massive computing power to process the data that you collect. And of course, you have to have machine learning expertise to process that data. At Quantcast, we have 18 globally distributed data centers, and we collect pixels and respond to ad exchange requests using that infrastructure. It is a requirement, both in our Measure and Advertise side, that we respond within 100 milliseconds to any site across the globe. And that 100 milliseconds is actually measured by the client, and it measured both hops, to us and back. So it actually includes internet traffic. We collect and process about 2.5 million transactions per second across both our Measure and Advertise products. And we have thousands of nodes in our MapReduce and live processing cluster that process about 30 petabytes every single day. And we have about dozens of engineers working on machine learning problems for the last 9 years. So let's talk a little bit about machine learning. We'll show how Quantcast built lookalike models at internet scale. First, you need a statistical model of internet. Quantcast Measure is one of the dominant audience measurement sites, and literally tagged hundreds of millions of websites destination. It observes over 500,000 media consumption events every second around the world. And what I mean by a media consumption event is someone like us come to a website and hit a website, a particular URL. This data constitute a behavioral model of the internet and enable machine learning models to basically help publishers understand their audiences and find advertising prospects for our advertisers. So what do we mean by a statistical model of the internet? We record features, we record and featurize media events. For example, when you come to a website, you have this cookie, which is this anonymous identifier of yourself, and then we track everything about that cookie. We record the time of the day you visit that site. We record what site you visited. We record the location you visited it from. And there's a lot of other features that we record about that one cookie event. And then we just basically create a graph of those cookies and how they interact with the media. So for example, in this particular example, you can see the cookie with this opaque number 2566, etc., visited smiles.com. We also see that that same cookie visited Cat's Video Network. Then we see that another cookie starts with AAC, visited, actually was shown an ad, and also visited Monster Truck mobile application. We track actually events across mobile as well as web. That other cookie lives in Brisbane, Australia, and also visited smiles.com. So the smiles.com is an event in common between those two cookies. And as a result, we can derive various different properties. For example, maybe those cookies are similar, or maybe the site, sites.com, smiles.com and catsvideos.com are similar sites. And then we do the demographics via inference. So we start with that media that we've tagged. So we've tagged the media sites here in the right-hand column. You can see that all those media sites that we've tagged. And then we actually use panel data. There's various different sources of panel data, and actually there's a lot of complexity about how you make sure that your panel data is not biased towards one or the other, or something, one or the other thing. But essentially, there's panels involved in any of that modeling. And from panel data, we actually know that some cookies in panel are similar. And how we know that? Because those two cookies in red visited kitties.com, and the two cookies in blues visited monstertrucks.com. And then we see that news.com might or might not be similar to monsters.com or not. It's the proximity indexes also matters. And then we have a set of anonymous cookies, and that's basically all of us, that we collected 500 cookies or 500 events per second. And then we see that those cookies visit kittens.com, and we also see that those cookies visit some other targeted media, and so we infer demographics of the anonymous cookies based on demographics of panel data. And so you can see that anonymous cookies now have different colors because of the strong similarities to the cookies in the panel. Then there is a audience similarity, as I mentioned. So if you have, for example, if you have that a connection between Monster Truck through the cookies to football.biz, you can see that these are the two common visitors, and they're connected by those two media nodes. And then you can see that in this particular example, 8 hops have no common visitors, so there's probably no commonalities between those sites. So in Quantcast Advertise model training, as I mentioned to you before, we actually take this, this event that we tag on your website, on the conversion event, what we call it. For example, a thank you page or a buy button somewhere. And then we monitor those tag conversion events. Then we score cookies by closeness metric to each other. So we see that those cookies that converted, they have similarities. And then we score media context by closeness metric, saying that your website is related to some other media. For example, flowers.com are similar to flowers800.com or some other website. And together, they make a behavioral and contextual model. And of course, richer the visit graph, the better the closeness score metric. That's why the data size actually really matters here. That's why you have to collect a lot of data for this modeling to work. I can't stress enough how important the data set is in this what seems pretty simplistic model. A really mediocre algorithm running on a very, very large data set is a better outcome than a sophisticated algorithm largely on a small sample. And so when we do the scoring, we score the entire internet. So we literally take the population of billions of cookies and we create a score for each of them as they relate to each model of advertiser. So there's literally no bad cookie. It's just the probability of event becomes slower and slower and slower as the features of the cookie becomes less and less similar to the feature of the cookies that convert. We use real value scores, real-time value scores. When you receive an event from a particular page, we put that event into the model scoring in real time. And the reason why we do that is because cookies actually change their behavior over time. So really to emphasize, the more data leads to better statistics and leads to more accurate scores. So I want to take an example to kind of explain the point a little bit further. And this is a real example, an illustration in the of a traveler site that is our customer. So what we first do, we define success. So we put our tag, which is literally this little URL that you can see, a little 1-by-1 pixel image, on a page where you purchase a ticket, on the buy button of an airline ticket. And then once that pixel is placed, we start observing. We just start recording events from that page. And we see that there's 2 people bought these tickets, airline ticket buy 1 and 2. So we just observe those 2 cookies. And then we look up in our feature store, what events do we have associated with those cookies? So we see that the first person likes the classical music, into sports, particularly football and basketball, like art, modern, cameras, high-end, travel, foreign languages, fashion, discount, airline tickets, of course, because they bought it. The other person likes cars and trucks, specifically trucks, art museums, travel, foreign language, location is in San Diego, real estate in multiple places, etc. How do we know those cookies? How do we know those features? Because we featureize those through our measure site, right? We create those features. And in fact, those features are tremendous space. In fact, there's literally billions of features. And if you think about it, our sparse model of features is it's a matrix that is about 3 to 5 million features in the cookie space. So it's scary to think, but we do have about, say, on average, hundreds of thousands of features per individual cookie. It's incredible the density of information that is if you have a significant volume of data floating. So then we reverse engineer the target audience. So the model, again, uses millions of those features to create a score for each of the features. So we see that in this particular example, art is a significant contributor. Travel and foreign language is a very significant contributor to the score. Photography is somewhat significant. What is also important is that we use the negative signal, and its negative signals are as important as the positive signals in the model. Why they're important? Because when you create a score in the model, when you actually look at the score, you see that we take the model with the scores, and we take the real-time bid request, which is a context in which we apply the model. So it is the publisher URL. So when you look at a particular page, say you went to CNN.com, and you see the ad, we receive that event from CNN.com when we actually bid on that opportunity to display an ad for you. We see who is the publisher, that is CNN.com. We see topics, maybe you're visiting the food section. We see the local time. We see the location where you're coming from. And we also see the behavioral information of that publisher as well, the music, romance movies, etc., etc. And so each request carries a probability of a conversion. And using that probability in various pricing strategies in the bid request, we actually create score. So what is interesting is that we apply bids, we submit bids on every single opportunity that comes to us. And as I mentioned earlier in the talk, we have 2.5 million transactions per second, 500,000 of which is a measure product and 2 million of which is actually advertised product. And what it is that it's a signal that we receive from all the stock exchanges, sorry, not stock, the advertising exchanges around the world, and they say, do you want to bid on this cookie? Do you want to bid on this cookie? Do you want to bid on that cookie? We score each and every single one of them with the probability of whether we believe that the cookie is going to convert for a particular ad. And then we bid on that cookie. We have an internal auction in our own site where we determine which of the customers of ours will benefit most from that event, and we bid on that event. We bid on every single one of them. It costs somewhere between 0 and a very, very small number per cookie. So that's basically how the modeling works. The lookalike modeling works, where we use a statistical model of the internet that we get from our measure data, and we apply that on events like advertising. But once you have the statistical model of internet, you actually can forecast various different trends, and sometimes it's hard, sometimes it's easy. So I wanted to show you a couple of interesting trends that you can easily look at if you're a publisher, and potentially infer some behavioral information about the population. So, for instance, let's take a look at this particular publisher, which is eHarmony. eHarmony is a dating site. In fact, all the publishers in my examples are going to be associated with dating, various forms. So here we see that right off the bat we found something interesting. By comparing California against Eastern Seaboard, we discovered there is such a thing as right time for males to visit eHarmony. We also see that you have a higher male to female ratio guys using eHarmony in California than on the East Coast. It's interesting, it's sort of just floating through by looking at the demographics and time of day. Another interesting example of sugardaddyforme.com. It looks like sugar daddies show up at that site at 5 a.m. Well, women are sleeping at that time. And largest concentration of women show up at 3 p.m. while presumably sugar daddies are working. And it looks like sugar daddies go to bed early. So by looking at that site, you can see, the publishers could figure out maybe there's an additional feature set like offline conversations that they could support or what have you. And the other one is this particular example. You see a whole bunch of dating websites. And you see that if you want to date a PhD, it looks like they're also going to be fit ones, because most of PhDs that show up on fitness signals, sorry, and you can see there's a very significant difference in that demographic on that site. So forecasting the sort of simple trends like that is pretty easy in the publisher side. I wanted to also talk to you a little bit about how to forecast trends in advertising models. And that's a lot harder than forecasting trends in publishing. And the reason for that is because advertising models literally look at millions of feature scoring in real time. And here's one story of an interesting, complicated trend that took us a little time to figure out. So there was a campaign that we were running on behalf of a customer. In June 2012, Quantcast began to work with a prominent airline company. The goal of the campaign was to increase sales on specific routes to San Francisco from around the country. And the campaign was supposed to run during the entire month of June. So Quantcast set out to find the travel enthusiasts who were looking to book flights to San Francisco during that time of June. So what we found when the campaign began? We start looking at the performance, and particularly on the sites that we deliver the advertising, and we pulled the report and noticed some really surprising information. You see that we found that there were several, the majority of our ads were showing across dentist sites. Something really had to be wrong with our model, so we became to investigate. This couldn't be right. Why would we advertise to dentists? So we have a lot of confidence in our models to really pick the behaviors that lead to conversions. In a short window of time in June 2012, the model decided that the best place to sell airline tickets was on dental sites. But why? After a lot of digging, we found that it turned out that American Dental Association was hosting an annual conference in San Francisco during October. When we learned that, we realized that the model had been right basically all along. So what did we really learn from that model? We figured out that the dentists are careful planners, and they look to book their travel months in advance. They have hotel and airline booking in October for conference, and they reach that peak in booking in June. So the model correctly determined that the best way to increase sales for San Francisco routes is to serve dentists going to that conference. Had the campaign had different dates, the model would have been behaving completely differently and shown the ads in different places. So when you have this statistical model that looks at millions of signals, picking up and rationalizing why those signals happens is a really difficult and tricky thing. And that's one of the examples why that is. In fact, this real-time direct response advertising is very different than the traditional advertising, which is brand advertising, where an advertiser, marketeer, comes to you and says, look, I want to reach out 25 to 34-year-old women that like string cheese because I know that that's my demographic audience. The truth is actually very different. The truth would be that the audience that really buys your product is entirely different. And so the models really sort of show, this particular example shows why that could be the case. So I hope that during this presentation that I showed sort of a few techniques in predicting publish and advertising trends online using statistical models of internet. And now I would like to take a few questions if you have any.